Hi, I'm Lisa and this is Threshold in China. We are going to look at a list released by an Australian think tank, ASPI. Basically, it tells you which country is leading in various technologies. So last week, we talked about high-performance computing, AI, and quantum computing, all of which the US ranks higher than China. Now let's continue. While China is trailing the US in genetic engineering, vaccine, and nuclear medicine. In genetic engineering, there is a very important technology called CRISPR. It is used to selectively modify the DNA of living organisms. Think of it as a pair of molecular scissors that can edit DNA precisely. This has huge potential for agriculture and treating diseases.
As of today, the number of global CRISPR technology-related patent families has exceeded 13,000. China holds the largest share of them, and the US is just a little behind.
In terms of patent flow, which points to technology export, the US stands out as the largest contributor to CRISPR-related patents, with a substantial number of patent filing in various countries. Approximately 12% of CRISPR technology applications from the US are directed to the World Intellectual Property Organization or the European Patent Office, allowing protection across multiple nations. On the other hand, approximately 90% of patents filed in China originated domestically. So patent numbers alone aren't the only indicator of technological leadership. While China leads in the sheer volume of CRISPR patents, the US demonstrates a broader international impact through its global patent filing approach. This difference in strategy is crucial in understanding the global influence of CRISPR technology development from these two countries. In a word, most of these Chinese patents on CRISPR have never crossed the border, while the US ones travel widely. In terms of vaccines, during the COVID pandemic, US companies have pioneered the mRNA technology. This is a newer technology that instructs cells to produce certain viral proteins to trigger an immune response, while China initially opted to the trusted and proven inactivated vaccine, which uses weakened or killed virus particles. mRNA vaccines typically elicit a stronger immune response but may have more side effects, while inactivated vaccines generally carry a lower risk of side effects but might offer slightly lower protection. And not until mid-2022 did Chinese firm launch their first mRNA vaccine for COVID. Also, if we look at the overall academic production like research papers, China is relatively weak in life science. The Nature Index also ranks countries and institutions by the number of scientific papers published in leading journals. In both biological science and health science, China comes at the second place right behind the US, but a distant second. So quite a far bit for China to catch up. Now let's move on to small satellites and space launch system. Small satellites, also known as CubeSats or nanosatellites, are satellites with masses ranging from 1 to 500 kilograms. They can perform various functions such as remote sensing, communications, scientific experiments, and technology demonstrations. And space launch systems are rockets that deliver payloads into orbit, for example, the small satellites. They can be classified into ground-launched, air-launched, or sea-launched systems, depending on the launch platform. The US and China are two of the leading countries in these technologies. According to the Center for Strategic and International Studies, the US has been at the forefront of these innovations, accumulating 1,763 payloads launched between 1992 and 2019. Russia comes in second with 840 payloads, and China comes at third place with 480 payloads. The US has also pioneered the use of air-launched systems such as Virgin Orbit's Launcher 1, which can provide flexible and economical options for launching small satellites. However, China is also working on a design for a reusable air-launched orbital rocket, which could offer a competitive advantage in the future. In terms of sea launch system, China has used its Long March 11 rocket. This means it can reduce the constraints of land-based launch sites. Both countries are also investing in new generation launch vehicles, such as the Space Launch System in the US and the Long March 9 in China. In launching small satellites from space, China has a unique advantage in its Tiangong space station. With the space station and the Tianzhou series cargo spacecraft, a more flexible approach to launch micro and nano satellites has been achieved. First, it enhances satellites' launch efficiency. By leveraging the space station as a launch platform, scientists can release satellites as required, eliminating the need to wait for suitable rocket launch opportunities or launch windows. It shortens the satellite development cycles and also enables the potential for prompt satellite development in emergencies. Secondly, this launch approach significantly reduces the cost. Unlike traditional methods that rely on large rocket payloads or the carpooling of multiple satellites on small rockets, launching from Tiangong Space Station offers a more cost-effective solution. This is achieved by sharing launch costs with other missions, such as regular resupply missions to the station, allowing satellites to hitch a ride, and thereby reducing the cost for each payload. Additionally, the flexibility in launch timing from the space station avoids the cost associated with delays and holding costs on the ground. And as space operations becomes more regular, economies of scale can be realized, lowering the cost of every satellite. This flexible launch mechanism therefore not only enhances efficiencies but also opens up space explorations to a broader range of research institutions and individuals by making it more financially accessible. Through extensive testing and validation, China has successfully deployed a CubeSat from the space station. While China demonstrates formidable strengths in several areas, it still faces challenges in others, particularly in achieving global influence in certain technologies. As both China and the US continue to push the boundaries of science, the world watches closely to see how these competitions will shape the future of global technology. We hope this series could provide you with insight into the complex dynamics of the US and China tech war. If you have different views or additional perspectives, please share them. We are interested to know.